Okay, continuing in our factoring packet. This is second page of 14.5 notes. Part 4, or exercise 4, factoring polynomials using the GCF method. Now remember, we're always going to start factoring by checking to see if there's a GCF. So, when factoring expressions, one of the gateway skills that is necessary for much of what we're doing in algebra for the rest of the course is this. So the word factor has two meanings and they're both important. So factor as a verb means to rewrite an algebraic expression as an equivalent product. And factor as a noun is an algebraic expression that is one part of a larger factored expression. Okay, so you can see here, these two are the factors, or the coefficient variables that were, or terms I should say, that were multiplied together to get the product. Okay, so if you're given any two factors, as we have in this example, then we've learned to use a distributive property in order to find the product. So now we're going to learn how to identify the factors if we're given the product. In other words, we're working backwards or undistributing, as we said in the last video. Okay, so to factor a polynomial using the GCF method, rewrite polynomials in standard form first. Find the greatest common factor of all terms and write the GCF in front of the leftovers and close the parentheses. Okay, now standard form, refresher for you, means highest exponent first. So for this one, we're not in standard form because this one has an x to the fifth and this one has an x squared. So I'm going to rewrite this with my 9x to the fifth first plus 12x squared because it's positive. Okay, now if I'm going to factor, the first step for us to do here is figure out what is the highest number that 9 and 12 can both be divided by. So I'm going to do my little method here. I got 1 and 9. Can't divide 9 by 2 evenly, so then it's 3 times 3, and then I know I'm done because I already used 3. And to factor out 12, I have 1 and 12, 2 and 6, 3 and 4, and I'm done. They don't have 9 in common, no 12, no 6, no 4. It turns out that 3 is the greatest common factor. Okay, so that means that I can take out 3, and I can also take out 2 x's because they both have at least 2 x's in common. So I'm going to take out 3x squared. Now, as I showed you in the previous video, what we're doing is undistributing, right? If we're undistributing, then technically we're dividing. So what we're going to be left with to go in our parentheses is going to be 9x to the fifth divided by 3x squared and 12x squared divided by 3x squared. And that's how we figure out what our leftover is. So 9 divided by 3 is 3. And if I have 5 x's, but I'm taking out 2, that means I'm left with 3. And I have 12 divided by 3, which is positive 4. And x squared divided by x squared is really just 1, and 1 times 4 is 4, so I just leave that be. Okay, and this is how we factor out a GCF. All right, let's jump on down to some of our examples. I have here 6x squared plus 10x. My x squared is my highest exponent, and that's first, so it's already in standard form. So now I have to figure out what are the factors of 6 and 10. Well, the factors of 6 are going to be 1 and 6, and 2 and 3. And the factors of 10 are going to be 1 and 10, 2 and 5. There are no other factors. So what is the largest number that these two have in common? Is 2. So I know I'm taking out a 2. Then I look back and see how many x's do they have in common. Well, this guy only has 1, so that means we can only take 1 out. And now when we're factoring, that means we're dividing out our greatest common factor. We're taking it out. So then we do our math here. 6 divided by 2 is 3. If I had 2 x's and I took 1 away, that means I'm going to be left with only 1. Plus 10 divided by 2 is 5. And our x's disappear. And we have factored. Okay, number 2. If I want to get the GCF over here, well, 3 has only one set of factors. It's a prime number, so 1 and 3. So I have to ask myself if I can divide 24 by 3 and get an integer, and I certainly can. So I know that 3 is going to be my greatest common factor of the coefficients. And now I need to see which one has the least exponent. But this one doesn't have an x at all, so that means I can't actually take out an x. The only thing that I can factor out here is a 3. So I'm going to divide both of these terms by 3, because that's what unfactoring is. This one cancels, I'm left with an x, minus 24 divided by 3 is 8. Okay, 3 is pretty easy. I'd like to jump around so we can do a little extra here. Let's look at number 9. Okay, 8, 24, 32. Now here's a little bit of a trick. If I was going to sit here and list all of the factors of 32, all of the factors in 24, and all of the factors of 8, that might take me a little bit longer than I want it to. So instead, when I have numbers like this, I'm going to ask myself, can I divide the largest number here by the smallest number here? And the fact is I can. 32 divided by 8 is 4. Awesome. So now I look at the middle number. Can I also divide that by 8? I can. So because I can divide both of these numbers by the smallest number that's here, I know that this 8 is going to be my greatest common factor. So I'm going to take out 8. And now I look back and see how many x's I can take out. They all have x's. But this guy only has 2, which means that's the most amount that I can take out. So 8x squared. That means I'm dividing everything here by 8x squared to see what's going to go left in my parentheses, what's going to be left for my parentheses. So negative 8 divided by 8 is going to be negative 1. And 3 x's take away 2 leaves me with 1x. 24 divided by 8 is positive 3. No more x's. And negative 32 divided by 8 is going to be negative 4, and there's 2 x's left. And I did forget a step. Can you catch me? Can you catch me? Can you catch me? What did I forget to do? Think about it. While you're thinking about that, I'm going to jump down to 12 because this one has more than just one variable. So first things first, find the greatest common factor between 16 and 12. I already know that that's 4. So I'm going to be dividing both of these by 4. And how many variables can I take out of each kind? There's 3 a's here and 2 here, which means I can only take out 2 from both of them. And I have 2 b's here and 3 b's here. 2 is the least, so I can take out 2 from each of them. Whoops. And what's left? 16 divided by 4 is 4. 3 a's take away 2 a's, leaving me with 1. B's disappear. 12 divided by 4 is 3. These a's disappear. 3 b's here, 2 there, leaves me with 1 b here. Okay, and I am done. And to revisit up here, I forgot to put it in standard form. So the actual correct response for this one is 8x squared times negative 4x squared minus 1x plus 3. And there you have it. Factoring out a GCF.